Hello and welcome to yet another video by EduPen channel. I am Dr. Badela, and in this video basically what we are going to do is that we're going to learn about impulse. Before we start with the video, be sure to hit that subscribe button and hit the bell notification icon so that you do not miss any content from EduPen. So today, as I've said, we are actually going to learn about impulse. So basically in physics, you always have to know your definitions and also formulas for each topic that you learn. But then fortunately enough, you can actually formulate your definitions from the formulas themselves. So if you don't remember a definition for a certain term, you can actually go at the back of your question paper and find the formula sheet and then try to find the formula that is used for that term. And after that, you can actually try to formulate a definition from the formula itself. So without any waste of time, let's get right into the video. So we have impulse here, which is equals to the net force multiplied by change in time. So that is the formula for impulse. So when you formulate a definition from this formula, basically what you will say is that impulse is actually the product because we multiply. So it's the product of the net force and the time at which this net force acts on an object. So if we go up here, we can see that impulse is actually the product of the net force and time for which the force acts. So that's how you actually get to formulate your definitions from formulas. So whenever you just forget it, don't panic, just go to the back of your question paper and try to find the formula. And after you found the formula, try to form a definition from it. So, however, from Newton's second law, we know that F net is equals to change in momentum over time. So let's find out the relationships between these components of this formula. But from other formulas, you already know that the net force is actually directly proportional to the change in momentum. And then you know that it is actually inversely proportional to the change in time. So whatever you have on your left-hand side as the subject of the formula is actually directly proportional to your numerator and inversely proportional to your denominator. So it's always like that in physics and in maths as well. So going further, if we make momentum the subject of the formula, we actually can say F net over 1, and then we cross multiply. And then when we cross multiply, we get momentum, change in momentum, which is equals to the net force multiplied by the change in time. So as you can see, we have actually made momentum the subject of the formula. And if you check this F net multiplied by change in time, it's actually the same as what you have on impulse. So with impulse, you also have net force multiplied by the change in time. Therefore, we can say that impulse is equals to change in momentum, which is equals to the net force multiplied by change in time. So we can see that impulse is actually equals to change in momentum, which is equals to F net multiplied by change in time. This actually takes us to momentum impulse theorem. So momentum impulse theorem basically states that impulse is equals to change in momentum, which we actually have seen by making the change in momentum the subject of the formula. And then we come and try to make an example of a scenario showing the relationship between the net force and the time it actually takes for certain thing or work to be done. So we've said that the net force is actually inversely proportional to the change in time. So let's say that we have point A and we have point B, and then we also have point A and we have point B. And then near point A, you actually have a box there. You have a box there. And then you are told that for point A, at point A, a force of 50 Newton is actually applied. And then down here, a force of 100 Newton is actually applied. So in this case, it will, let's start with the 100 Newton force that is actually being applied. And that is actually our F net, right? So 100 Newton force is actually applied to the box at A, and the aim is actually to push it towards point B. So this box will move from here to here, from point A to point B. Maybe it will take 2 minutes. It's just an example, it's not the exact thing. And then for a force of 50 Newton being applied to the same box, it will actually take it much more longer than it would with 100 Newton force. So you can see that with this one, maybe it will actually take 4 minutes instead of 2, because the force is smaller. So the greater the force, the lesser the time. The more time it takes for work to be done, the less net force that is actually being applied. So that's how you can actually see the effect of the net force, and also on the effect of net force actually on time, and also the effect of net force on momentum. So the other thing that you need to actually familiarize yourself with that is important is actually graphs. So with graphs, basically what you have to do, like in this first graph, you actually can see that there's a rectangular shape below the graph. So what you need to do is that you actually need to calculate the area below the graph in order to find the impulse. So whenever you are given a graph, just find the area for the shape of the graph that is being given. So for the first one, we have a rectangle. So we are actually going to calculate the area below the graph, which is rectangular shaped. So we are going to find the area for a rectangle. And then with the second one, you can see that it's triangular. So we can actually find the area below the graph. So in other words, we can find the area of this triangle that is here on this graph. So that's how you do it. But we will learn about it as we go further in the next videos. Right now, we just have to focus on the impulse itself and then try to understand the main aspects of it first. So without any waste of time, let's get right into an example. So as I always emphasize, try to outline the information that you are given first before you do any calculations, so that you do not make any mistakes. Right. So the question says that we have a 150 Newton resultant force actually acts on a 300 kg trailer. So you go ahead and write a trailer, and then you write all the information about the trailer. They say the net force that acts on it is equals to 150 Newton. And then they say the mass of the trailer is equals to 300 kilograms. And then it is said that calculate how long it takes this force to change the trailer's velocity from 2 meters per second to 6 meters per second. So you also write this information as well. So they say that the initial velocity of the trailer, it's 2 meters per second. And then our final velocity, we want it to be 6 meters per second. And then they go further and say in the same direction. So assume that forces act to the right, which is the direction of motion of the trailer. So we can write the direction of our velocity. It's to the right. 6 meters per second to the right. So we have all our information outlined. So basically what we need to do right now is to actually check if all the given information is actually in the correct units for us to use in formula that we are actually going to use. So we can see that our net force is actually in newtons, it's okay. We can see that our mass is actually in kilograms, it's okay as well. And then we can also see that our velocity is actually in meters per second. We were not given speed instead of velocity. So we are required to calculate how long it takes this force to change the trailer's velocity. So in other words, we are required to calculate the change in time. So we know from what we have already learned that F net is equals to change in momentum over change in time. Right. So we actually have what? We have the net force, but we don't have the change in momentum to use this formula. And then we also don't have what? Time to use this formula. So maybe we can find one of these and be left with only one to calculate. And that is, we can actually calculate how much is the change in momentum. So without any waste of time, let's get right into it. So we know that momentum is always conserved, right? So what we can do is we can find the initial momentum. So let's write it, initial momentum. So initial momentum is going to be equals to momentum is equals to mass multiplied by velocity. So our mass is actually 300 multiplied by initial velocity, which is equals to 2. And then we have how much? We have 600 kilograms meters per second to the right. And then we go ahead and calculate the final momentum. So the final momentum is equals to P, which is equals to mv. And then we substitute, it's 300 multiplied by 6 this time. So we are going to have 1,800 kilograms meters per second. Please use your calculator if you're not sure so that you do not make any mistakes. To the right. So now we actually have the initial momentum and we also have the final momentum. So it means we can actually find the change in momentum. So change in momentum is actually equals to the final momentum minus the initial momentum. So that is going to be 1,800 minus 600, which is equals to 1,200 kilograms meters per second. So we are actually done with that calculation. And so basically what we have now is that we actually now have change in momentum, which is 1,200. And can we actually calculate the change in time? Yes, we can, because we already have our F net and also we have calculated our change in momentum. So without any waste of time, let's get right into that calculation. So we are going to say F net is equals to change in momentum all over change in time. And then we continue to say that we substitute our values that we have. The net force is 150. And then we also have change in momentum, which is 1,200 kilograms meters per second over the change in time. And then what we do is that we cross multiply. We have 150 change in time, which is equals to 1,200. Therefore, change in time is equals to, you divide both sides by 150. You divide both sides by 150. We say 1,200 divided by 150, which is equals to 8 seconds. So that is the answer to the question that we were actually asked. So be sure to actually try to calculate these things on your own, or pause the video along the way in order to try to find it on your own before you actually see like the final answer of the question. So I hope you really enjoyed this video. Be sure to hit that subscribe button again and the bell notification icon so that you do not miss out on questions that we actually try to solve on EduPen channel. See you on